All right, good morning, folks. Thursday, happy Thursday. Last time I recorded, I think it might have been Monday, but it was for Tuesday. So you got the assignment on Tuesday. You got like 2.2a, shortened version. We're going to do a couple more check your understandings. These ones are, I think, a little bit shorter, but your assignment is going to be longer. And as I mentioned before, you'll get today and tomorrow to do it. So, check your understanding number 3 says for which values of the variable is each radical defined. So for a, it's got the root of 27x squared. I wrote something down somewhere, I can't find it. The root of 27x squared, it's saying for which values of the variable is each radical defined. So in other words, what can the x equal or not equal? What set of values will it make this defined? If there's a negative under here, that's not defined. It's imaginary number. This is a little bit similar to when we're talking about non-permissibles at the bottom of a fraction. You can't have anything that makes it 0. Here, you can't have anything that makes it negative. So really, this 27, it doesn't matter. It doesn't matter. All that matters about it is its sign. It's positive, so we're good so far. That just makes it easier. Okay? Just worry about the sign here. Now here, you have to decide, can it be negative? Can it be 0? Can it be positive? Okay? That's one way of looking at it. Like, maybe I'll just write it like this. Try -1, 0, +1. When this is x squared, my fat marker made that 2 a little bit, whatever. But if we put in -1 in there, -1 times -1 is +1. 27 times +1, positive number. That works. 0, excuse me, 0 squared is 0. 0 times 27 is 0. The root of 0, 0. No problem. That's okay. The only time that you would have an issue with that is if you had like a root of like, I don't know, 3 over x or whatever. Then it can't be 0. +1. 1 squared is 1, blah, blah, blah. It's positive under there. You're good. So what that means is x is an element of reals. Okay? It can be any number, and it's going to work. All right? Cool. Now I wanted to say, like, oh yeah, that's what I was going to say. When you try the +1, you think, well, of course it would. If that was -27, and we had like a different number here, an odd number, that's when sometimes the positive won't work. Okay, and I'm sure we'll get to that. This one's the 4th root of -12x cubed. So we have a 4th root, so it's an even root. Okay, so what that means is it can't be negative in here. It can be negative if it's an odd root, and we'll see that. I think you're going to get an example coming up. Yeah, you get an example coming up. Just for funsies, imagine this is 3 or 5. Let's just say it's 3. If this is -1 cubed, -1 times -1 times -1 is -1. Negative times a negative is positive. That would mean x could be negative. Couldn't be positive because that would leave the whole thing as a negative. All right? So here, you can just try these if you want. So, and eventually, I think you won't have to kind of go through this little testing. Excuse me. You'll just go, oh yeah, okay, I can see this. So if you try -1, if we put a -1 in here, -1 times -1 times -1 is -1. -1 times -12 is positive. Cha-ching, that works. If we put a 0 in, 0 cancels everything. So that works, right? Because 0 times -12 is 0. The root of 0 is 0. +1, 1 times 1 times 1 is 1. 1 times -12 is -12. That doesn't work. What that means is x can be 0, can be negative. So it has to be less than or equal to 0. I hate not seeing faces and reading and seeing, are people okay and what's going on. But I guess that's what the reply button is for if you have questions. Okay, so that's number 3, CYU number 3. I'm going to do number 4. So CYU number 4, this is page 99. All right. For which values of the variable is each radical defined, and then simplify the radical. Okay, so we're doing the same thing. Excuse me, we're doing the same thing for the first part, and then the second part we're simplifying. So the first one is 45a squared. The root of 45a squared. A, in this case, can be anything. I'm not going to do this little check every time, but like you can, please. The squared, this is, I don't care about the 45, I just care about the sign in front. It's positive, so I can just ignore it. -1 squared is 1. That's positive in there. 0 kills everything, that's 0. That's positive. 1 squared is 1, that's positive. Everything's positive, doesn't matter what you put in there. X is an element of the reals. Or A is, sorry. A is an element of the reals. But now we have to simplify, we have to bring out what we can. That A can come out, right? Because the root of A is A. Now 45, we want to break this down and bring out the pairs. So 45, 5 goes into that 9 times. 9 is 3 times 3. I can take a 3 out. 3A, but a 5 stays in. 3A root 5. This would be your answer. Now, if this went too quick for you, I'm going to spend a couple seconds on this. For anybody who's got this, maybe skip ahead to A, or sorry, to B. So for this, 45, the root of 45, I'll do a different color. The root of 45 equals the root of, the prime factors are 5 times 3 times 3, right? 5 times 3 is 15, 15 times 3 is 45. I can take those 3's out, but I won't skip that step just yet. Root of 5 times root of 9, right? 3 times 3 is 9. Root of 5 times 3, which conventionally we would write as 3 root 5. Hopefully that makes sense. Please, please, please let me know if you need me to go over it. All these blue dots all over the page, man, I'm pressing too hard. I have this weird memory as a kid of my dad being like upset with how hard I pressed when I was printing. The root of -27, he would deny now for sure. B to the 9. Okay, now we're getting interesting, hey? So notice, first of all, here we have an even root. This is the square root. Like you could put a 2 there, but that's redundant. It's like kind of like putting a b to the power of 1 is just b. You don't need to write that. So this is a square root, so it's going to be even. 27, who cares? As far as figuring out like what can be equal, the negative is what matters. If this is negative times a negative, then we're good. That gets rid of the imaginary number situation. So if you try a -1 to the power of 9, all you got to think is whether it's even or odd. If it's even, -1 to an even power is +1. -1 to an odd number is negative. So you have -1. -27 times -1 is +27. That's what we want. We want it to be positive or 0 under here. 0 makes everything 0. +1. 1 times 1, 9 times is 1. 1 times -27 is a negative number. X has to be less than or equal to 0. So now we got to simplify this. I'm going to do it in 2 ways. Let's look at the 27 and then we'll look at the B because it's different. So with that 27, if I have -27, I can say -3. Let's just pull that negative out right away. -3 times 9, and then 3 times 3. So I can pull the 3 out, and the -3 stays inside. And then with the b's, variables are a little bit different. Am I always holding this in the right spot? I know I'm moving it around. I sure hope you guys are catching everything. Sorry, I'm looking down as opposed to out. But if we're talking about the b's now, b9, b to the 9, sounds like a vitamin. B to the 9 is b times b times b times b times b times 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. You don't have to do this every time. Just I'm showing you kind of the step by step. You can take out pairs, right? 2, 3, 4. B to the 4. Didn't give myself a lot of room here, did I? 3b to the 4. There's 1b left over. That's our answer. Okay. For those of you that want me to show just a little bit more about this, the root of b9 equals b times b times, I'm going to run out of room, 3, 4, 5, 6, 7, 8, 9. Whew, made it. Okay, so now let's kind of pull them together in pairs. So that equals the root of b squared. That's what these two are. Times the root of b squared times the root of b squared times the root of b squared times the root of b. See where this is going? So the root of b squared is b times b times b times b times the root of b, which equals CD stack b to the 4 times the root of b. Car alarm going outside. Pretty sure that's too far away to be my car. I'm gonna check. Yeah, no, not ours. No, Jackson had the car, didn't know if it was out on the street. Nope, it's right there. Okay, that's B. Got 2 more to go for the CYU. Part C. Excuse me. I'm catching a cold. A little bit freezing. I don't know if you can see my layers. I've got a t-shirt and then I've got a hoodie and I'm wearing my robe. The 4th root of 7z. First of all, what can z equal? We first need to find the values of the radical for which, the values of the variable for which the radical is defined, kind of like the permissible values. There's nothing fancy going on here. We have an even root. We've got a positive sign. Z is not to any power, so it has to be positive. If you throw a -1 in there, it becomes -7. That's imaginary. 0, the root is 0. That's easy. 0. 1. The 4th root of 7, 7 times 1 is 7, it's a positive number. It'll be an ugly number because it's a 4th root, but it's a positive number and it's doable. Z is greater than or equal to 0. Make sure you have the equal part. Unless, like I said, that Z is like at the bottom of a fraction or something like that. Now, as far as simplifying this, we cannot make any, like if we do our factor tree for 7, it's like 1 and 7. Okay, guess we're done. The Z, there's just one of them. This doesn't change. You're done there. That's it. That's all you do there. All right, one more example. D. Cube root of 24 y to the 5. Cube root of 24y to the 5. So we have that cube root, odd, which means this can be negative. Okay, which means it can be negative because you can take that out, but it also means it can be positive. And that has more to do with the fact of what you can kind of take out of it, like how you can simplify it. So I'm going to show you the simplification first. Well, I'll just say this because that's what it is. Y is an element. Is that how it goes? Why is my brain stopping on me? Y is an element. There we go. Of the reals, because of the odd root. Put a -1 in here. You can actually take it out. Like when we simplify this, that's what I was saying. We're going to simplify and show you, and I keep clearly changing my mind. If this is -1, we can take 3 of them out because it's the cube root, because it's odd. We can take 3 of them out, and then if it's y squared left inside, and it's -1, -1 times -1 takes care of it. And of course, 0 and positive, we have no issues with that because this is positive in front. So like I said, this one might be easier to see when you simplify it first. So let's start with a 24. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. 2 root 3. The cube root of 24 is 2 root 3. If it was the square root of 24, it would be 2 root 6. Okay, I think I did an example like that last day. So we can take the 2 out, 3 stays in. So it's 2, I'm going to leave a space for the variable this time, cube root 3. Now, y to the 5, y times y times y times y times y. This is what comes out. 1y comes in, 2 y's stay behind, because of the cube root. Does that make sense? I hope so.
I hope so.
Tomorrow, I think I mentioned this, maybe I'll write it in the little preamble before I post. Tomorrow I'm at the school the entire day. I won't have my kind of equipment here with me, so I will be able to answer, like, you know, simple-ish, straightforward questions, but the recorded questions will have to wait for those that come tomorrow. I apologize. Nothing new tomorrow. Okay, you have today and tomorrow to do the rest of this assignment, because it will be, you know, size large-ish. Numbers 6 to 13, not to 3, page 101. All right. Yeah, so take care. Let me know if you have questions, people, please. Anything. And if you're not happy with the answer, please say so. Like I mentioned, I think that with those feedback forms were good. It seemed like the biggest thing I needed to change. And really, I think it was only 2 people just wanted a bit more detailed feedback on their assessments, which is cool. So that's what I'm trying to do. If that's not cool, let me know. Okay, I'm done talking. Bye. How do I stop recording?